As promised, I wanted to provide you with a few examples of how we prove that theorems are true. We are going to take the hypothesis and lead to the conclusion of each of these proofs, all right? They're generally structured in that format of if this condition is met, then this thing is true. It may not be articulated clearly as an if-then statement, but basically we're gonna be given a certain condition and we're gonna go through logical steps called deductive reasoning where we use the given information or previously known or understood facts and concepts to work logically from point A all the way down to point, D, E, or F, however many steps it takes for us to get from what we're given to do what we're supposed to prove, all right? So the first one that we're going to engage with is our vertical angles theorem, which states that vertical angles are congruent. And so here we understand that angle 1 and angle 2 are vertical angles. How do we know that? It's given. Now this is an explicitly given statement here, but moving forward, I would expect you to see that in the picture, all right? And say, oh, those are vertical angles. Oh, those angles are congruent, all right? But we're gonna prove right now that they are congruent. Along with that, I know that angles 1 and 3 together make a straight angle. Right? This seems like a non sequitur. It doesn't have anything to do with angles 1 and 2, but hold that thought for just a second. These angles are supplementary. All right? This is one of those things that is given in the figure. You do not need to distinguish if something is given as a statement or if something is given in the picture, but I'm making that note that sometimes given information is shown to us or given to us in the picture without it being a formal statement. Sometimes it's in the picture and it's formally stated, but here we're going to say that angles 1 and 3 are supplementary. That we can tell from the picture, which means I'm not going to say that they're supplementary unless I'm going to use that information. That tells me that the sum of their measures is 180 by the definition of supplementary. I'm abbreviating supplementary, S-U-P-P. All right, which means that the measure of angle 1 is equal to 180 minus the measure of angle 3. If I subtract the measure of angle 3 from both sides, using the addition property of equality, then I come up with this statement. Now, I wanted to get this far so that I can do the same thing with angles 2 and 3. If angles 1 and 3 are supplementary, well, guess what? So are angles 2 and 3. All right, so that's kind of a neat trick. Angle 2 and angle 3 are also supplementary. That's given. Again, it's given in the figure. I'm not going to state that it's in the figure, but we understand that. The measures of these angles sum to 180 by the definition of supplementary, which means that if I subtract the measure of angle 3 from both sides, dang it, of this equation, I find that the measure of angle 2 is equal to the same thing that the measure of angle 1 is equal to. All right? So if two things are equal to the same thing, then that means that they are equal to each other. That is the transitive property of equality, all right? So if the measure of angle 1 equals this thing, and the measure of angle 2 also equals that same exact thing, that means that the measure of angle 1 is equal to the measure of angle 2. I'm going to write transitive POE here. But you could make you could make the claim that this was also substitution POE. All right? I'd be okay with actually either one of those answers. All right? If those angles have equal measures, then those angles are congruent by the definition of congruent. All right? We have shown that given vertical angles, those angles are congruent to each other. We went from step to step to step, logically showing, hey, if this is true, then I know that is true. There may be some things that come off to the side, all right? These things are all independent of each other, but these depend on the statements above them. This depends on the statements above them, all right? And then these pieces right here tie it all together. So one thing that is beneficial for you to consider doing is understand which parts and pieces do I need to have, and in what order do I need to make all of these statements in? Well, this statement requires nothing else before it or anything else after it, all right? But this right here, I can't make this statement alone. I want to make sure that I use that information. I can't make this statement without having first said this. I can't make statement 4 without having said statement 3, without having said statement 2. So we use all that information together to come up with a logical way in which we should write the order of these steps. Again, there's some flexibility we can have there, but generally speaking, this will be your proof for the vertical angles theorem. Next, we have the congruent supplements theorem. And you know what, folks? This is going to be the same exact proof. All right? This is going to be the same exact proof. Are you ready for this? Instead of having these statements written in this way, all right, instead of having that first step, I don't even need to use the picture here, but we're given that angle 1 and 3 are supplementary angles. We're also given that angles 2 and 3 are supplementary angles. That's given information. But we do the same exact line of thinking to show that angles 1 and 2 are congruent to each other. Can you see that logic? Pause for a moment and look at this. Here we have angle 1 and angle 3 are supplementary angles, which means that the sum of their measures is 180, which means that the measure of angle 1 is equal to 180 minus the measure of angle 3. All right, same logic as before. Angles 2 and 3 are supplementary. Same types of statements, just with angle 2 instead of angle 1, for the same reasons as previously discussed. Well, if these measures are equal to the same thing, then these measures are equal to each other, which means that those angles are congruent. The point here is to show you that the proof of this theorem is the same as the proof of the vertical angles theorem. It's just not in the context of two lines intersecting or two pairs of angles made up of sets of opposite rays. All right, here's what I would like for you to do. I would like for you to take this same approach, and how would you handle the congruent complements theorem, where the sum of the measures is not 180, rather the sum of the measures of the angles is 90. All right, so let me show you what that looks like. It's going to be very much the same proof. All right, it's just that instead of dealing with supplementary angle pairs, we're dealing with complementary angle pairs. And we're going to show that these angles 1 and 2 are in fact congruent. Our second column is going to look very similar to the second column of the last two proofs. Our first column is going to look very similar to the first column of the last two proofs. See if you can fill in those blanks and do this proof of Theorem 1.3, the congruent complements theorem. I can't wait to check that. Theorem 1.4, this is a good one. Given two right angles, all right, so angle 1 is a right angle, angle 2 is a right angle. All right, we're given that information. We're going to prove that angles 1 and 2 are congruent to each other. This proof isn't too shabby. We're going to start with angle 1 and angle 2 are right angles. That's given info, yay. Next, I'm going to say that the measure of angle 1 is equal to 90. And I'm also going to say that the measure of angle 2 is equal to 90. That's the definition of a right angle. We defined right angles back in our first lesson. Maybe it was our second lesson together, I suppose. But the definition of right angles is that they're angles whose measure is 90 degrees. Which means now that these angles have the same measure. You can call that transitive POE, or you can call it substitution POE. All right? If the measure of angle 1 is 90, and 90 is equal to the measure of angle 2, then the measure of angle 1 is equal to the measure of angle 2 by the transitive property of equality. You could call this substitution, and I would be super cool with that. Substitution POE. Those aren't entirely interchangeable, but I think they could both apply here. And therefore, angle 1 and angle 2 are congruent by the definition of congruent. If they have the same measure, then the angles are congruent. That's what congruent means. All right? So statements, reasons, statements, reasons, statements, reasons. Can you make two statements on one line? If it's appropriate to do so, then yes. All right? Here we're basically saying the same thing. Oh, if this is a right angle, its measure is 90. If this is a right angle, then its measure is 90. I could do that in separate steps if I wanted to, but why not just write them together? All right. Theorem 5. All right, Theorem 1.5 says angles that are both congruent and supplementary are right angles. Here are the statements. And so I'm going to talk us through this, and your job is going to be to fill out the second column. All right? So first of all, Angles 1 and 2 are congruent. This given statement gives us two pieces of information. First, it says that angle 1 and 2 are congruent. Then it says that they are supplementary. All right? So I'm going to make those given statements just kind of at separate times. We can manipulate the way that we structure our proof depending on how we want to think through it. If you want to put all the given all at once and right at the beginning, then that's fine, but sometimes it's helpful to kind of break those pieces apart and utilize them separately. For example, angle 1 and angle 2 are congruent. That's given information, which means that their measures are equal by the definition of congruent. So I just took that first piece and I made some statements around that first piece of the given. Next, angles 1 and 2 are supplementary angles, all right? So angle 1 and angle 2 are supplementary. That's given, but we know that that means that the measure of angle 1 plus the measure of angle 2 is 180, because that's what supplementary angles are, angles whose sum is 180. That's the definition of supplementary. I then substitute, this is a great example of substitution, where I put in place of the measure of angle 2, I put angle 1's measure. I took this thing and I put it in place of that in this equation to now have an equation that has the measure of angle 1 plus the measure of angle 1 equals 180. All right? And you're already starting to think, well, if I added two things and they're the same thing and I get 180, then those things have to be 90. We're getting there, right? We'll get right there. All right? So that means I have 2 times the measure of angle 1 is 180, divide both sides by 2 to get that the measure of angle 1 is 90. Well, if the measure of angle 1 equals 90, and the measure of angle 1 is equal to the measure of angle 2, then the measure of angle 2 is also equal to 90. Which means that angles 1 and 2 are both right angles. All right? Can you fill out the second column reasons for each of those statements? I gave some verbal clues, but at the same time, you are applying your understanding of each of these concepts and what they are stating. All right? Did I use substitution? Did I use transitive? Did I use APOE, MPOE? All right? Where can we put those things? Do we use any properties of congruence, or are they all properties of equality? All right? Think through each of those statements. All right. That is the end for this first round of doing proofs of the theorems that we are given in class. All right. In the future, I'm going to hope that I can assign you with the task of proving the theorems when you are after you write down those theorems themselves. All right. That we can make those logical connections, and you can make some progress and have some growth with respect to proving theorems.